Hi students, let's look at the questions on the number sequence for geometric figure. So geometric figure just means shapes, which is number sequence involving shapes. So what you have learned previously for number sequence involving numbers, all the concepts that you have learned previously, for example, identifying the rules of the number sequence, finding the next few terms, write down expressions for n term, use the expression for n term to find out values for a specific position, and check whether a particular number is part of a number sequence. All these 5 concepts are being applied in number sequence involving geometric figure. So you can think of geometric figure as like application questions. So let's look at this question 2 over here on page 64 of your textbook. So after you have tried this question out, you can actually do page 91 of your workbook, question 1. So in part 1, they say copy and complete the table. So all you need to do is to count and fill in the table. So for figure 3, how many small triangles are there? So you count 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 of them. So for figure 4, how many triangles are there? You count also. So you can pause the video to count. Okay, so after you count finish, you should get 25 small triangle. And let me draw you to the number pattern over here. So for 4, right? How can we express 4 as? So 4, 9, 16, 25. Do they ring any numbers to you? Like, are there any form of a special number? Okay, so if you notice, these numbers over here, they are called square numbers. So for 4, it can be written as 2 times 2, which is 2 square. 3 can be written as 3 times 3, equals to 3 square. 16 can be written as 4 times 4, which is 4 square. 25 can be written as 5 times 5, which is 5 square. And 36 can be written as 6 times 6, which is 6 square. So that means my next two number will be 36 and 49. So for 49, it can be written as 7 times 7, which is 7 square. So now they ask you to find the number of small triangles in the 20th figure. Okay, so let me teach you a shortcut. So once you can identify the expression for n term, you don't need to count the number of triangle one by one. So let's say if you want to count the number of triangle one by one, you have to add up the number of small triangle for each new row. For figure 1, it will be 1 plus 3. For figure 2, it will be 1 plus 3 plus 5. For figure 3, it will be 1 plus 3 plus 5 plus 7. And for the 20th term, right, it will be 1 plus 3 plus 5 plus 7 plus 9 plus 11, so on and so forth. Very complicated. So for this case, you can actually write down an expression in terms of n first, and after that, you find the number of small triangle in the 20th term. So we are actually looking at this question here. We write down an expression for n term, and we use it to find out a value for a specific position. So in this case, the position that we're looking at will be 20th position. So let's look at the number. So whenever we want to find an expression in terms of n terms, right, we need to find a relation between the figure number, and the number in each small triangle. So when the figure number is 1, I notice that the number of small triangle will be 4 square, which is 2 square. So which is 2 square, not 4 square, 2 square. When looking at figure number 2, I notice that the number of small triangle will be 3 square. And when looking at figure number 3, I notice that the number of small triangle will be 4 square. Do you notice any pattern? So if you notice, right, whenever my figure number is 1, the number of small triangle will be plus 1 square. So for this case, the number of small triangle in the 20th term will be 20 plus 1 square. So 20th figure will be 20 plus 1 square, which is 21 square. So 21 square equals to 441. So this is the number of small triangle in the 20th term. So now let's look at part 3. So for part 3, they asked us to write down expression for n term. So I noticed that for 20th term, the number that I need to square is 21. So when it's the n term, the number I need to square will be n plus 1. So the number of small triangle for figure n will be n plus 1 bracket square. So this is my expression. So for part 4, so after you have found out the expression for the n term, now they're asking you to apply the expression for the n term to find out the value of n for which the figure has 81 small triangle. So I know that the general expression for the small triangle for figure n is n plus 1 bracket square. So when I have 81 small triangle, I let my number of triangle be 81. So all you need to now do is to find out what is this value n over here. So I know that n plus 1 bracket square is the same as writing n plus 1 times n plus 1. So I can square root it. So I square root n plus 1 square. So I can find out what is these square numbers that make up n plus 1. So n plus 1 will be equals to 9. And to find out what is n, my n will be 8 because I minus 1 on both sides. So that means the figure number will be figure number 8 that has 81 small triangle. So let's look at the next part, part 4. So after you have used the expression for n term to find out a value or a position that contains the 81 small triangle, the next type of question they will ask you is whether this particular sequence contains a certain number. So for this case, whether it contains 99 small triangle. So same thing also. Take n plus 1 bracket square equals to 99. So in order to know whether this particular figure exists, my n must be a whole number. So I need to square on both sides. n plus 1 square equals to square root 99. So n plus 1 will be equals to 9.94. Okay, so let me shift the thing around. Okay, so this is what I'm talking just now. So when n is a whole number, that means this particular number is part of the number sequence. But when n is not a whole number, that means this number here is not part of the number sequence. Why? Because n is a position of the term, so they must be whole number. For example, if you're running a race, do you ever heard of like I'm ranked number 7.5 position? Not possible, right? Because you can't have a position which is like between 7 and 8. So it will be position 7 or position 8. There's no 7.5 positions. So similarly for this type of questions here, when you're looking for the particular n term, this n over here represents a position in a number sequence. So there's no, so all n number, right, must be whole number. So since you know that n plus 1 will give you 9.9498 7431 9.987431, and when you solve for n, it will be 8.94987431. And since, and how do you conclude? So you just conclude since n is not a whole number, the sequence does not have 99 small triangle. So this is it. So after you have done this question, you can apply the same concepts for question 1 on page 91. So this is on page 91 of your workbook. If you're unsure, please ask.